when we have a circuit with more than two sources, we don't do anything any differently. We're still looking at one source at a time, but this time in each step we're going to set two sources to 0 instead of just one. So in this case, we're looking for I1 right here. That's the current through R1. And we have three sources. We have a 12 volt source, a 6 volt source, and a 3 amp source. So when we're focusing on the 12 volt source, we're going to set our current source to 0 and our voltage source to 0. And doing that, we have an open circuit where the current source was and a short circuit where the voltage source was. And then we're going to solve for the current through the 2 ohm resistor. Well, when we do that and the middle section becomes open, we now have a series circuit with just a 12 volt source and 2 resistors. So I1 prime is the same thing as I sub s in this case, which would be E over RT, where E is 12 volts and RT is 2 plus 4 or 6 ohms. So we've got 2 amps of current there. The next thing we have to do is decide the direction. Since our only voltage source has a positive terminal here, that's going to be the direction of our current. It's going to leave the positive terminal, come back to the negative terminal. So I'm just going to do a little up arrow there to indicate direction. And then let's move on to another source. So we set this aside for now, and we'll bring it back later when we want to put all of this together. So I'm just going to put I1 prime is 2 amps that away, up in the going up. Now next we want to work with the 6 volt source. So we're going to set our current source to 0 by opening that up, set our 12 volt source to 0 by shorting that out, and then we're left with a simple series circuit again with just the 6 volt source and then 2 resistors. So I1 double prime is I sub s in this case as well, E over RT, where E is now 6 volts over 2 plus 4 ohms or 6 ohms. So we've got 1 amp this time. And now the direction, of course our current's going to leave the positive terminal of this source and return back to the negative. So our current is going to go down through R1, so in that downward direction. So I'm going to make a note of this. I1 double prime is 1 amp in the downward direction. Notice they're opposite each other in this case. And now we've got our current source. So for the current source, we're going to short out both voltage sources. There's a short and a short. And we're left with a current source and 2 parallel branches, which are a current divider. So we're going to use the current divider rule. And I'm going to use the quicker version. You might want to learn this because when we get to AC, this version is a lot easier to use with your complex numbers. So the current divider rule, for instance, says that if I'm looking for I1 triple prime, I'm going to take R2 over R1 plus R2 times the total current coming into the divider. Okay, so let me just say that again. If I'm looking for this current over here, I'm going to take this resistor and put that over the sum of the two. I know that's a little counterintuitive, but that's what makes this equation work so well. So basically I've got 4 over 6 times my 3 amps coming in. So 2/3 of the current of this current source would be going through the 2 ohm resistor, which is 2 amps. And of course I have to think about direction. So if my 3 amps is going this way, I'm going to have my 2 amps this way. So that goes down through I1 here. Okay, so make a note of that. Whoops. Did I go too far? I did. No. Ah, there we go. I1 triple prime is 2 amps in that downward direction again. So what we've got is, it looks like 3 amps in that downward direction, 2 amps in the upward direction. So that means that I1 would actually be 1 amp in the downward direction. Okay, so these are opposed to each other. It's not 5 amps because they're not going the same direction. If they were all going to the same direction, it would be. So superposition tells us that I1 is 1 amp in that downward direction. If you want to check, let's do a little Ohm's law here. So if we have 1 amp going through 2 ohms of resistance, we have a 2-volt drop there. Let's see. We have 3 amps coming up this way. If we've got 1 amp going out this way, then another 2 this way. So 2 amps times our 4 ohms means we have an 8-volt drop here. And let's just see, if we were to do KVL through this branch, we'd have +2, whatever this is, let's just call it VI. VI, no, let's not do VI. Let's call it VX. Okay, let's just say minus VX. Plus 12 equals 0, so VX equals 14 volts. And let's see what happens over here. We have a plus 14 minus 8 minus 6 equals 0, which it does, and there we go. But really, superposition is good for any time where you need to find one thing going on in your circuit and you don't necessarily need everything else. So work through that again if you need to, and we'll work some more problems.